Hi everyone, I'm Thomas.
And I'm Annum.
So this we are doing like an evolution simulator. So about like a introduction, our project is involves simulating the evolution of artificial life forms in the virtual environment. So what we did is like using like grips to like using a grip by like a Python program language to show how the genomic which represent by action probability. So what is our goal is like studying like a evolution process and also like the impact of environmental input condition. So our project milestone is like set up the simulated environment to maintain the state and also define the individual condition about and also a genetic algorithm parameter. So we also create a visualization and integrate it with the simulator. So what we did is like a UI UX part. So we show like how do we evolution about the simulator and also like showing like the result and things visually.
So here are the different parts of the code for our simulation. We have the configuration, which controls the grid size, the mutation probability, and the tick intervals. And then we have the graphics, which Thomas worked on, which controls the user interface and the different constraints on the grid size. And then we also have the model, which controls the creature creation, actions, location, and genomes. And then finally, the state, which controls the creature additions and removals, and then the generational changes. So in the creature class, this code over here creates the creatures with an ID, a color, a speed, and a location. And then this function allows creatures to reproduce and combine their genomes. And moving on with the state class, the state class is maintaining the state of the simulation, and to do that, it creates a grid with a given size, and our size is 24 by 24. And then it also is able to track creatures based on their location and their identification, and it checks to see if creatures are within the grid limits based on the size. The state class also includes functions to add creatures and remove creatures, and then also to move a creature, which clears the creature's initial spot and then moves it to a target location. So these functions also in the state class are able to retrieve the target location and execute the move. And then it also checks if the target location is out of bounds before moving. And this function sorts the creature actions by speed. And finally, in the state class, it controls the generations in the simulation. So it's able to filter out older generations, produce a new generation, and also update the simulation with this new generation. And then we also have our operation and direction classes, which kind of handle the actions of moving and the direction, which is up, down, left, or right. And this piece of code here identifies the target location based on the directions, and it returns a location.
Okay, so go back to like a visualization. So I'm doing like a UI UX part. So what I did is like I'm coloring the cells and on and 24 and 24 grid and with like a trail, like a speed and also color visualized and distinct showing visually. And also like the graphic is tracking like the individual and the population levels change like depends on different environmental and different like different data like speed and also like the sanctuary, all the things stuff, all the data we can change it and then analysis of the trail and emergency of the propagation. And also like a genetic class, we also have created a genetic and also combine like a different genetic and then also we show the sample of action. And this is like our evolution simulator. This is like how do we want. So like you can see different colors moving around, and then like it's because like we are showing like a different data and also like different century. So you can see like a result, and yeah, just keep going with my teammate.
Yeah, so here's our evolution simulator. And as you can see, when the video first started, the grid was kind of up here in the upper left corner. And these little boxes, which represent creatures, would adapt to move up to this corner so that they don't die. And then eventually we added this code, which allows users to change the constraints. So at the end of the video, I updated the constraints to be in the lower corner. And as you can see, the creatures eventually adapted to move down here into the lower corner.
Okay, so what is our future plans? Like the first main things like reinforcement learning, so we can like compare like the efficiency and also adaptability about like evolution. Also, we want to having like a variable condition, like testing different environmental condition, like adding more data, so we can test more different and more difficult result. Yeah, this like our future work. Okay, thank you for listening. Thank you.
Thank you for listening.
I think so.